become like automatically enabled?
Yes.
Like that would mean you'd have to go out of your way to disable it for some reason.
I think that the create button has like create. I think it just says create one and then like create or create audio only is what it's called. Whatever. So like you kind of do. Okay. We're gonna shoot. Is that what? Oh, I see what's going on now. Okay, we're gonna show this screen. Now I can. Okay. Great. I don't know how to exit full screen now. Let me show this one. Okay, that ends up over there, so that works out. What? Okay. All right, visible? Yes. Okay, setting that visible. And I want to have chat showing over on this screen too. And I will take this and move that far over there so y'all don't have to look at it. And there's a full screen. Okay, we're in business. All right, now let's try to make it more than just one person in here. Okay, progress. Actually, 100% increase in people. There you go. That's called math. Where is CSE E220? Oh, God. Yeah. Up the stairs, the stairs. Okay. All right. Is anyone still trying to join, either here or online? Yes, no, maybe so. Oh, there you go. See what? Okay, why is a bunch of robust stuff happening? I'm so confused. So, okay. All right. So, so as we like see if anyone else jumps in, but okay. So this is design patterns. So if you've never heard of design patterns before, you're pretty much just playing a game of guess. But hey, that's okay. That's what we're just trying to stall time. I mean, have fun. So design patterns are basically software design. In object-oriented programming, there's a bunch of people who figured out, hey, there's this super cool idea that we can have these general type of ways of structuring and building together objects in order to do very common actions. You can think of this as like, okay, so you have individual Lego bricks, right? And so the Lego bricks get built together to build a house. Well, if you have like a blueprint for an entire house, then you can just duplicate that house a bunch of places, like, you know, apartment complexes and stuff like that. And so the way it might work is that if you have a house where it's like, okay, I have these specific needs, then this is a good blueprint to use. At the same time, there's not necessarily one right answer. If you have a house with those needs, it doesn't mean that using this blueprint is the best case scenario, right? So there's some wiggle room there. But ultimately, the idea is that if you have a standard kind of tech problem and it's represented well by a design pattern, you can use the design pattern to get the job done there. Okay, so I'll probably do like a 30 second to 1 minute touch on the individual questions afterwards, but we'll kind of just treat it as a who has studied software design. So, and if you've been to previous meetings, the guy, you better know it. All right, let's go. How do we turn this up? I feel like we can turn the volume up a little bit. Good luck, have fun. You would be wrong. It is 23. Okay. Yeah. So the Gang of Four is the standard de facto book on design patterns. It is literally called Software Design Patterns. It is well worth reading. I may or may not have a PDF that I can pass to people if anyone's interested. But yeah, there are a lot of freaking design patterns in there. You don't need to know all of them, and like half of them are almost never used anyways. But there are a couple key ones. And so I think it's like the key 5 that I normally try to pick out, like one from each of the 3 categories, and then a couple others that I frequently run into. I think all of those will end up in here. But yeah, there's 23 of them. And this is just the ones by the Gang of Four. There's a bunch of other patterns for other types of languages, like non-object oriented ones, as well as other design patterns that they didn't even know existed, back in the 70s and 80s when the book was written. Doom, doom, doom. Singleton, yeah, it's kind of in the name. So singleton design pattern, it literally makes sure that there is only one instance of a class ever. So normally with object-oriented programming, every class is designed as basically, using a blueprint example, kind of overloading it again, but every class is a blueprint of how to build an object of that type. And so most of the time, you want a class to be able to have multiple instances. It's very rare that we talk about the idea that a class has one and only one instance. Does anyone have a good example of where a singleton is useful, right? Where's there a class that only has one instance? Game manager. Yeah, a lot of game stuff and a lot of kind of, well, we need to work in kind of higher level logic into some type of object-oriented situation. Use that type of thing all the time. Yeah, you had something? So scanners, not quite. Your scanner, so your scanner class in Java does have a constructor that can take in different input streams. So what's your name too? Nick, right, okay. All right.
Math, like the math classes in the different languages. Does that count as singleton or?
So I see what you're going for, not quite, because normally it doesn't have.
It's not really an object.
Right, it doesn't have an instance associated.
Got you.
Yeah, okay. So here's an example. Most UI systems and other things like that, right? So for example, in Android, right, your main Android app activity is a singleton class because your app creates one class instance that manages the entire state of the app. And there shouldn't be more than one app at the same time. Okay, so why is it a class instance? Because you extend some type of Android activity class in order to get access to a whole bunch of other things that Android does for you with managing and initializing state, making sure that the right functions exist and those can be called, constructing the object, and all of that type of stuff as well. And so there's a layer of indirection there that necessitates a new object, but you only ever want one of those. And so singleton it is. Woo. All righty. Okay, Ranger, I'm counting on you. Next question. Pattern separates the creation of complex objects. Honestly, the Kahoot music is just such a jam now. It's amazing. Whoa, builder.
Let's go.
Wow, this is really shaking things up. So yeah, okay, so your builder object is basically, if you've ever seen the pattern where you do one thing and then you do a method on that, and then you do another method and another method and another method, so on down the line, we'll see that. So in Java, your string builder class is kind of a great instance of this, right? So with string builder, you make a new string builder instance, and then you call .append over and over and over again. In other cases, so the type of stuff that I work with on sponge development, which is Minecraft, means we use builder stuff all of the time because often you have a lot of different items and options that you want to set. For example, when you're building an item in Minecraft, you might say, all right, we're making a new item builder. The type of it is, say an apple, but then you have all kinds of other options. Does it have enchantments? How, what's the quantity of it? What effects does it have? And so on down the line. And so all of those variable options work very well with the builder interface. Factory method.
Hello?
I think there'll be another question for that. Hello. So,
Okay. Yeah, can you hear me?
yep. Yeah.
Okay. I thought the meeting was at 7. That's not good. Well, I have an idea. We can just go through this and I think we can just go through it at 7, not 7, at like now, and then see what we can do from there.
We already announced that the meeting is going to be postponed to 7.
Okay. Well, that seems like a better idea. Yeah.
Yeah. I mean, so we'll go with that and it'll be fine. So we might want to just consider switching rooms though. So we'll cross that bridge when we get there.
Yeah, who knows? Maybe 221 will be open.
I think it does end up being, so that'll.
Did we get lost last night?
Yeah. Yeah. So, because like it ended up being online, but like it's been 2 weeks, so who knows if it'll still be online. And it's just better we don't have any unforeseen interruptions at all possible. But
Okay.
yeah, I think factory method will be another one, but if not, I'll talk about it at the end. Which one here is not a design pattern? Meta question. Yeah. Dependency injection, yeah. So it's not a design pattern per se, but it is kind of like a software pattern. More accurately to say is that it's probably a design pattern, but it's not one of the gang of 4 design patterns. Okay. Did it not? Okay, no one here. Okay, so no one on the leaderboard got it. So that's it. Okay. Delegates the creation of an object, allow implementations to choose the best fit.
I know this one.
Yeah. So hint, it's probably not the one that the last question was. And it's probably not the one that we just established isn't a design pattern. There you go, factory method. Okay, so that kind of answers your question. It worked out nicely, I guess. But so yeah, so your factory method is basically you have this factory that says, give me a new object. So the standard example that's generally given is if you have some type of like paint application and you have a shape tool. And so your shape tool says, okay, the current shape selected is a square or a circle or a star. And that goes to the backend application and says, okay, when they use this, make a new square or circle or star or whatever. And then, move that onto the canvas and do what you need to do with it. Right. So that's kind of your classic example of that. Now, why is that helpful? Well, if you need to be able to create a certain instance of a particular class in some type of variable way, that's pretty much the only way you can do it. Right? Because you can't just say, the other way is you can say, if this is a string, then make a new, or if this says square, make a new square, right? Because you have to say new square, right? You can't say new class of this name, right? Unless you're using a factory method, in which case you can. There's also similar patterns that do other things, but yeah. Okay, Ranger, I believe in you. This pattern allows new behavior to be added to existing objects through wrapping. Existed objects. Okay, well, apparently 2 years ago, I couldn't grammar. So how much you want to bet that I noticed it in the meeting too, and then just never ended up fixing it?
Is that happening at this time?
Probably. Yeah. Okay, decorator pattern. Yeah. Okay, so extender is one I made up. They have nice names, but not that nice names, unfortunately. So yeah, so the idea of a decorator is you're kind of basically adding, this additional kind of sprinkles on top of something to basically be able to get it to do additional things. So there are alternatives to the decorator pattern for a lot of things. I personally don't like it, but it is a kind of common one that you see used. So a kind of similar example to the decorator type stuff you might see is kind of what you were getting at with the scanner class in Java, right? That is kind of similar because it's basically you have an input stream and then your scanner class just does everything it needs to with the input stream, but adds a whole bunch of additional methods and other fancy stuff on how to work with it. But that is kind of more of a better example of another pattern, which I don't know if we'll talk about, but if we do, I'm going to spoil the answer because it's here, which is the strategy pattern, right? And so the strategy pattern is, wait, no, it's not that. What am I thinking of? The facade pattern. I don't know if it's in here, but the facade pattern is much closer to that, where you're basically adding a new interface onto things, but not necessarily hanging a whole bunch of logistics about the object. The decorator is kind of similar to that, but a little less so. I personally don't like the decorator pattern, so I'm not going to talk about it anymore. So, hey, Ranger, woo, buddy, we're playing Kahoot because things. I don't know if you saw the announcement, but yeah. Pattern allows logic to be handled by a separate controller. Oh, I know what the last question will be. There's no way I would have done it any other way. Yeah, strategy pattern, right? You can think of this like your game, right? Your game has a strategy. It picks one of those strategies and it rolls with it, right? So the strategy might be, is the AI easy, medium, or hard, right? And so you're not going to have everywhere that your AI is trying to do something, switch on this case and do this different thing, right? What you're going to want to do is say, okay, anywhere the AI stuff is needed, I'm going to have some object that represents easy AI. And if there's a decision that's going to be made, I'm going to call whatever instance of the AI strategy that I have and say, hey, pick the next move, here's your parameters. And so depending on what strategy instance we are, whether we're in easy, medium, or hard, it'll do different things to make the game harder, right? So that's actually a really common pattern that's used kind of all over the place, especially in games. Okay. Ooh. All right. Last question. Design patterns are dependent on the programming language used. And the computer music is just so good. There's a remix of this that's super cool.
Oh my God.
Let's see. Woo!
Yeah.
Good job, Ranger. So, Rovas still lives. Woo! Okay, so say no to Rovas. Was that you, Eric, or
What's that?
that was you, Eric?
No, I came in like 11.
Who was say no to Rovas? Okay, all right. I guess no one wants me coming after them. Fair enough. And then Gare.
That was me.
Kudos. So, all right. Have you done design pattern stuff before? Or?
No, I've seen it for like 5 seconds of programming from those two.
There you go. There you go. Oh, all right. So yeah, there we go.
Remember box, definitely, we had a whole lab where we had to use the singleton.
Let's see.
Yeah, it's a good spring.
Yeah, you just like mentioned game before.
I think-
design patterns.
I think this is probably okay. First question: patterns, the creation of objects. Yeah. What other patterns were in here that we didn't get to talk about? Talk about builder. Talk about dependency injection. Dependency injection. I can't explain that. Right. You need to Google that if you want to know what it is, because it's kind of complicated. Vacuum method singleton. We talked about builder, delegate. Okay. Delegate is relatively simple enough. Delegate is just kind of passing things down the line. So literally delegating. Some languages actually have delegating stuff built in. So Kotlin has that, for instance. Okay. Strategy, we talked about visitor. Okay, visitor we didn't talk about. Visitor is super cool, right? Basically, if you have some type of arbitrary like class structure and you want to do different things depending on the type of that instance, you can use a visitor pattern. So the de facto standard place where the visitor pattern is used is in programming languages. So in programming languages, you have something called an abstract syntax tree, which is basically the entire structure of your program. So for example, if you have like 1 plus 2, well, 1 is a different thing than 1 plus 2, and they're represented in memory differently. So 1 is some type of integer literal that is represented as some type of thing in the AST, while 1 plus 2 is some type of binary expression that's represented in the AST. And so the binary expression is something that has the operator, in this case of plus, and then it has 2 operands, right? The left-hand side, which is the number 1, which is itself some AST representing 1, And then the right-hand side, yeah, right-hand side now, which is 2, right? And so you want to do different things. So for instance, when you evaluate something in the AST, right, evaluating a number literal is very different than evaluating a binary expression, right, which is very different than evaluating a function or other complex things. And so the visitor pattern allows you to do that. So it's a really helpful one to know. How many software patterns? We don't even need to look at that. It's new behavior. Decorator, yeah. Talk about extender isn't a thing, and then strategy was another question. Right. Cool. Yay! I don't have prizes or anything because this was unplanned, but Ranger, I'll give you something later. I don't know.
I'll give you an Among Us question.
But then you won't have half of that. Wait, is it just showing this again? Okay. Congratulations, you won again. All righty. See, look, it was the old style. Oh my God. This is when we were at Little Hall. Oh my Lord. I remember this meeting now. Oh my God. I made shape cutouts. It was adorable.
Lit 207. Oh my God.
Dude, this meeting was adorable. There were literally like 5 of us. So good times, good times. Good times. Okay, anyways. Yeah. All right, Eric. All right, you need to come solve for 15 minutes. I did my piece, now it's you.
All right. You have another Kahoot.
I mean, yes, but I don't think you want to do another Kahoot. I mean, okay.
I mean, it's probably far more interesting than what I had to.
Oh God, I think I need to log in again. Yeah. I guess we're doing another Kahoot. Gmail. Okay, this is gonna be pretty whack. Oh wait, yeah, okay. All right, actually, this one will go faster because I don't need to talk about everything as we get there. Okay, screen share is still going? Is that the case? Anyone online?
Yep, it looks good.
Okay, cool. Okay. Okay, so this Kahoot is about error handling. And if I recall correctly, the entire Kahoot is designed around, God. The entire Kahoot is designed around where every question is basically asking you what is the best method of error handling for this particular problem. And so first off, sometimes there's like no right answer, right? So this is like semi-biased Kahoot ultimately. Okay, so one of which is sentinel values. So a sentinel value is basically something like, okay, for example, like in C, there's a lot of things that kind of do this, right? So C, a sentinel value is basically, say you want to take the square root of a number and it fails. And so if the square root of the number is invalid, it returns -1 instead, right? Like we've all seen methods where it does like the return -1 thing on error, right? Okay. I think the next one is like it's either return codes or like return arguments. And so basically what this means is that the function has a separate type of thing where it returns information about whether it failed or not. So like in Go, for instance, you return a success value as well as the error as multiple returns. In C, sometimes there's things where you can do like, you pass in like some variable by reference, and that's what the error actually is. I think there all might be one for basically checking like status codes. It's like in C, if something overflows, it sets a status. So you have to check for the error status code, which is like a global variable. So that kind of has its own mess to it. Then the other one is error handling. The other one is exceptions. So we all know what exceptions are in programming, right? You're throwing exceptions for things. But at the same time, note that there's a performance cost to exceptions. But at the same time, in general, you have to handle the exception should it occur. So it can be good if there's cases where it's like, yes, an error might occur and we want to make sure you handle it. And then the last one is result types. final one. So result is like in Rust, you have a result, which is either a success or an error. It's similar to multiple return values, but you can't ignore the error value, right? If you return multiple things, you can just ignore the second one. If you return a result, you have to explicitly unwrap the result and check to see whether it is an error or not before using the value. So once again, a bit better with API stuff. Okay, there you go. That's the best rundown I can give you in the limited time and without knowing what any of the questions are. So let's go. I want to at least give some guidance so it's a learning experience and not just guesswork. Okay, writing a list of strings to a file. Okay, I see what I did. So sentinel value, result value, checked exception, and unchecked exception. Gotcha. I think it's generally these consistently throughout, right? Checked exception, right? Java uses checked exceptions for this. This is generally good. And so the reason why, so sentinel value, not good, all things considered, because once again, you have to check for that. Result value, so there's no result of writing list of strings to the file, right? So once again, you can ignore the result because there's no useful information there. Checked exception versus unchecked exception. Okay, anyone want to kind of weigh in there? Yeah.
Wouldn't this unchecked exception crash the whole program?
No, I mean, no more than a checked exception per se. So, but there's kind of something you're getting at, which is basically true. Okay, so what does it mean for an exception to be checked? More specifically?
Is it like catching the exception?
Yeah.
Is it like checking a specific exception versus catching all exceptions?
Not quite. All right, I'll spoil it here. Your checked exception needs to be caught. It needs to be either caught or rethrown. Otherwise, compilation will fail. If you have an unchecked exception, then you don't need to actually check it or handle it or whatever, right? So an unchecked exception is good for like really rare situations. So for example, dividing by 0 in Java, there was an unchecked exception. Because can you imagine how painful it would be if anytime you tried to use divide, you'd have to check for an exception? It'd be really painful. Now it's more correct because you can obviously make that mistake, but the assumption is that you're being careful enough with your input values where it's so rare and just if you get to that point, it's pretty much broken that you don't worry about it. But if you're writing something where it's like a calculator, then obviously you have to handle that case. Because otherwise, as Eunice was kind of saying, if you're not looking for that unchecked exception, it will indeed end up crashing the program, right? If it's not caught by something higher up. Okay. All right, the rest of these will go through pretty fast here, I think. Index of the largest number in an array. We need this music louder. There we go. Result value. Yeah, sentinel value is actually an approach that's generally used, which is probably why other people put that too, right? So we're a lot of pretty confident with returning -1 for a lot of things. Result value is probably a bit of a better approach, once again, because it's trying to, you're looking for something and then trying to see if it's there, right? You don't want to accidentally use the value when it's really -1. Right? That's how you get things like buffer overflows or other types of really bad situations that can lead to security vulnerabilities. I'll try to justify things a bit less, and if you have questions, you can ask me. Entering a map/dictionary. I actually have no idea what I put as the right answer for this. So my opinion may have actually changed on this one. We'll see. Okay, good. I did it right. Either of these two are perfectly fine, right? Result value would be something like returning nullable. That's possible. An unchecked exception is also pretty good. Sentinel value is really bad, right? There's a particular reason why it's bad, right? What happens if you have that sentinel value inside of the map itself? You can't tell if something was in the map or was not in the map. right? This is actually a problem that Java has, right? Because it returns null in these cases. So if you ever get back null from a map, you don't know if it was or was not in the map. There's another method that is called contains key you can use to check this. However, contains key and then get will perform two lookups. One lookup to find the value and see that it exists, and the other lookup to actually get the value, which means computing the hash code twice, computing everything else twice, going through all the steps twice. So it's not a very performant solution. Okay, I'm not liking these names. So, oh God, we have 4 minutes. Ah, we gotta go quick. Right, so yeah, check exception, right? Error that you should be expecting and trying to handle, right? File not exists is something that you should always be looking for in your program. Divided, uh-oh. Yeah, unchecked exception, right? Talk about this. Simply because it's just kind of such a rare error. Passing in an argument doesn't meet preconditions. Now we get back to design by contract stuff from 2 weeks ago. Wow, this came together so much more nicely than I expected. Unchecked exception, the same thing, right? Preconditions are things that you expect to be true by whoever calls that function, right? If the preconditions are violated, then pretty much all bets are off, right? The base definitions of your preconditions are that these are what must be true in order to use that function. If you use them and it violates the preconditions, then all bets are off, right? The developer made a mistake in that process, right? So kind of like square root. If you call square root with a negative number, right, and the function says this only takes positive numbers, that's not the function's fault. It's your fault for calling it, right? Or whoever's fault ended up calling it down a way. So that's why it's unchecked.
Question.
Yeah.
So like in cases of like, let's say you have user input, right? So is it in that case, like what?
I think we'll get there, but if not, ask me after. Because we got 4 to go in 2 minutes, barely enough time. Casting an object to a string. Ooh, it's a weird one. I might actually say checked exception, general nowadays. This is kind of conflicting things, is the short answer. But yeah, in general, this is a more low-level operation, which is probably why I went for this. And Java does have things like instance of you can check, but ideally doing this in one swift motion and handling the case where it's not is probably better. But since it is low level, there's understanding for why it might not.
We should probably, it's 6:59, so we should probably switch over.
Oh yeah, we're in a different Zoom. I forgot about that. Okay, we do need to do that.
No, we're gonna stay in the same Zoom link. Yeah, I asked D-Rod to change it on.
Okay, can we finish the Kahoot though? There are 2 more questions. Woo! It's all very unchecked exception. So yeah, basically because just the expectations. And as said before, these vary and my opinions may have changed, but you can fight me on it after. Ooh, this is an interesting idea. Doom. Yeah, functional value, right? Because this is a wrapped node class, so having null for that condition is perfectly fine. And because it's an implementation, you don't have to worry about as much other stuff, and performance is more important. For anyone on Kahoot, or anyone on Kahoot, for anyone on Zoom, we're gonna switch over here in just a minute. Kaijin, you about ready? Give it up. Cool. Yeah, check exception. I'd actually say unchecked exception is probably the right answer here now, right? And the reason why is because basically, if you have multiple things all going to the same registry, how does any one of them handle a situation where it's duplicate? You just can't, right? It just needs to fail at that point. Longer of us. Doom. Okay, well, I mean, interesting battle today. All right, who is that? Thanks.
I was also saying no to robots.
God damn it. Okay. All right. Cool. Kaijin, you all ready? Oh, my mask. Can you start the recording there?
Let me see.
So are we switching Zooms or?
No, we're not
First
fixing it.
thing.
Okay, cool.
Already had gave everyone the correct Zoom link for it. Well, this Zoom link at least.
It's already recording. Right, so. There, you already started recording, right?
Oh, then that's fine.
I think so because I don't see start recording button, I just see stop and pause. So I'm guessing it's okay. Yeah, so I'm about to start. So yeah, welcome everyone towards the second sequence in our Python workshops and collaboration with NSBP. So in this GBM, we're primarily going to focus on some major libraries that are not only popular, but really helpful for physicists and scientists and basically data science in general. So it is a lot of stuff to cover. So I'm going to try to cover like the key points and the highlights of each library. So without further ado, let's see.
Okay, so are we gonna or you want me to take over on this?
Yeah, you can do the first. Yeah, you can do.
Okay. So
we're in the middle.
yeah, so basically, for Python libraries, we have a method of installing those libraries into whatever Python directory you have. So we have pip installation, which you would put in your terminal, pip install, and you can essentially install any library you want that's within the pip database. So that includes things like matplotlib, numpy, and scipy, which are three of the main libraries we're going to talk about. And it's for pip installation, it's somewhat not that easy to install, but you can find how to install pip on your computer with this link here. I'll also would put that in the chat as well. You'll have to, what you need to do is install pip and have it as the same path as your Python installation. So it'll literally say path in all caps, and you need to have that as your same Python installation. But an easier way would be using Anaconda. It basically comes with a whole suite of software, including Python EDIs, or editing software for Python, and it comes pre-installed with a surplus of different libraries, including libraries we mentioned. instead of using pip, you'll use conda in your terminal. So whatever you use, if you use a Mac, Linux, or Windows computer, for both pip and Anaconda, you can use pip install. For Anaconda, it would be conda install whatever your library you want. So for example, conda install numpy. So you can figure out how to download Anaconda with this link. So there's also something called Miniconda, and if you don't want all of the heavy software, Anaconda comes with, Miniconda essentially just gives you Python and the method of installation with conda. So you can use conda install whatever you want. So you can use those two methods, whatever works for you. I personally would recommend doing something like Anaconda because it's more streamlined. But you can use whatever one you want.
All right, so I guess I'll take it over. So there's a couple of slides. I'm going to cover like some of the popular libraries. First up, we have NumPy, which is pretty useful and very cross-disciplinary. We can pretty much use it across different fields in STEM. So essentially, it is a library for managing arrays, their operations, storage, and basically everything to do with homogeneous data storage. This just means that the data type of all the elements in an array should be of the same type or of compatible type. So as the name like slightly implies, NumPy NumPy gives you in-dimensional arrays. That just means you can specify as many levels or as many dimensions as you want. So normally in Python, the default go-to equivalent will be a list, which is just one-dimensional, just a list of elements. But NumPy, if dimension is 2, you obviously have a matrix. If dimension is 3, you have essentially a cube, and you can get arbitrarily big with the number of dimensions you have. And in the NumPy languages, not language, but in the context of NumPy, these are also called axes. So dimensions and axes are synonymous. So some of the common types of arrays that they have are ones, zeros, and I. These may seem weird at first, but let me explain. So each of them have their own functions in NumPy to create them. If you call NumPy.ones and you specify like a shape, it gives you an array of only ones. Similarly, NumPy.zeros gives you an array of only zeros. And NumPy.I gives you a general version of the identity matrix, which is just having the diagonals as ones and all other elements being zeros. So these are pretty frequently used throughout different fields. And then they also handle operations. Again, some of the common ones include range, but they call it like a range. So a range is just it's just like a starting number and stepping up and increasing like 1, 2, 3, 4, 5, and so on until a stopping point. And the rest, don't worry, I will cover all of them in the upcoming Drupal notebook demo, but there's way more beyond what's just listed here. This is just some of the common ones. Let's see, okay. Next we have SciPy. So this is a ginormous library. It's really like just a bundle of smaller libraries, if you think of it that way. Essentially, it has everything from clustering to linear algebra to signal processing, which is getting more specific. So essentially, it's just a giant library with different submodules with tools for a variety of disciplines in STEM. So you should check out the documentation for that because it's pretty much like impossible to memorize function names and everything. I'm going to cover some, again, I'm going to cover some key topics from here in the upcoming demo. but this is really useful, especially and personally in the past, I have utilized their statistical sub-modules for machine learning and statistical learning. So that is really useful if you need specific distributions. So this is called SynPy. This probably will be the most useful for physicists. And the original goal or the original objective of the library is symbolic computation and representation, which is basically like back in high school when you were learning algebra, you had to like add different variables together, like x plus y or x times y plus another term. Remember like the quadratics and polynomials. So it basically represents expressions in math, and you can even perform calculus over an algebraic expression. But this functionality goes beyond just simply representing them. You can do different simplification, like factorization operations, and you can compose functions on top of each other. So it's really math focused, especially in algebra and calculus. But one of their special submodules, which obviously gives even more submodules underneath that, goes towards physics, and it's called SynPy.physics. And again, in the corner, just to let everyone, in the corner of each slide dedicated to each library, there's going to be a short snippet saying how to install it with either pip or conda, but it pretty much follows the same pattern for installation, as Dora said earlier. So matplotlib is a major plotting and visualization library. It pretty much gives you almost every possible type of plot or graphical visualization you will need in data science or in in an analytics context. So obviously the histograms, the bar charts, and scatter plots, line graphs, all those common ones are definitely supported, and you can pick them up easily by reading their documentation. But it also has some cool features like animations and like a slideshow of images. And it works really well with NumPy. So all of these libraries I mentioned so far have pretty good interoperability when you use them like in the same Python script.
Yeah, and just I just want to go in a little bit more with matplotlib. So you can also matplotlib is heavily integrated with a lot of workflows for physicists, especially when you are trying to publish any graphs you have of any data sets you have. If you want to graph it, matplotlib is one of the core things physicists use to have quality graphs of whatever you're doing. So if you want, let's say if you're trying to image the Milky Way, and if you want the proper coordinate systems, and you can use matplotlib to change the fonts, change the sizes of those, and have whatever image you're trying to create and overlay any kind of analysis you have. So matplotlib is also used for that as well. And it's not limited to 2D. You can do 3D plots of essentially anything you want. So it's a really versatile library in that sense.
Mm-hmm. So the rest of the slides are about plotting. I'm not sure, Dora, do you want to take over?
Yeah, so those are more towards the demo of matplotlib. So if you want, we can go into the demo of NumPy, SciPy, and SynPy first, and then I'll take over with the matplotlib side of things.
Yeah, that sounds good. So yeah, along with the same order as the slides, we have also prepared a demo Jupyter notebook, or this is a Google Collaborate, so it's more accurate to say just collab. But essentially, as I mentioned before, I'm going to demo some of the key features of each library I covered so far. So
Can you paste that link?
Yeah, sure. Okay, never mind. It's chat's over here. It's too many. Okay, so
You find this in the chat.
yeah, I got it. It's right here. I'm gonna post it to everyone. Okay. So let me know if you can access it. Should be able to. So
Also, I think I can post like a PDF of everything already plotted. So if you just want to print it out and use it as reference, I can supply that too. I think I have to create the PDF first, but yeah, just
yeah, we can just post it in the Discord sometime after.
yeah, that's what I'm.
Yeah. So just have it handy. Okay. Okay, so first up again, as I said, NumPy has so many different types of prepared arrays that follow certain patterns or follow certain rules, but you can create empty arrays, ones arrays, which obviously just have ones in them, and then an I, which again, it's based off of the identity matrix, but generalized, meaning it doesn't have to be a square matrix. You can specify different values for the number of rows and the number of columns. And here are some really useful functions from NumPy. So initially, as you can see in this line, you can easily convert a Python list into a NumPy array. But you can also cast higher dimensions, like a list of lists would be equivalent to a 2D array in NumPy. Now, I'm going to go through some common operations I talked about earlier. So this is pretty similar to range in Python. They just add an A in front of it. And you can repeat items. You can create an in-dimensional array by using reshape. Obviously, you just reshape the number of elements along each axis or dimension. So that's what reshape does. Flattening is just like collapsing the entire structure in dimensions. You only want a single dimension, just like a regular Python list. So you could have a matrix or a 3-dimension or even a higher dimensional array. But if you flatten it, it's literally just iterating over every dimension. It's like a multi-for loop essentially, going through every element and then bringing it down to only one dimension as a single linear list. So this is what flatten does. And this is not unique to NumPy in Python, but a lot of other languages like R and Julia also have this. If you add a constant or do any like arithmetic to an entire array, that gets done element wise. So the same operation is done to each element across the whole array. So this initially was starting at 1, I believe like 1, 2, 3, ... But I added 4 to the whole array, or added 5. Yeah, never mind. It started at 0, but I added 5 to the whole array. But that just tells NumPy to do it to each element. Now moving on to SciPy. This library is way too big to even demo a generalization of its capabilities. So I'm just going to go through some some that people are familiar with from like high school math. So obviously you can integrate, this is just a bare quadratic function, y equals x squared. Though the plus already done, I'm not gonna run that. Interpolation is not from high school math, I believe, but like if you've taken numerical analysis, you probably know what it is. It's just trying to use a few points and then trying to find an appropriate polynomial that estimates the function, the true function, which you don't know. And optimizing, that's just like taking the derivative and finding the maximum or global max or maximum minimum along some function. And yeah, this is probably a bad choice of the specific function, but it's just a quartic or fourth degree function, and it slightly dips down right here, and there's a local minimum where this line crosses, and that's just the line cross, the x value is just copied over from what the optimization function from SciPy gave me.
Okay. So how would you like where's exactly where you can like create any kind of function you want? So what line of code is that?
Yeah, so you could use the default Python syntax, like using the keyword def, and then define a function with a name and parameters after that. But in a demo, I use a anonymous or nameless function using a lambda, basically. Let me try to find it. Here it is, func, F-U-N-C, yeah. But yeah, as long as like it's a callable of some kind that takes in at least one parameter, it should work. So, but for this specifically, there's several minimalization functions in SciPy, but minimum scalar, like I believe, only takes in a function that has one parameter. So it's just f of x, that format. So, but there's other optimization functions that can take a function with multiple parameters, x, y, z, etc. Okay, so now let's move on to SymPy. Again, it's used for symbolic representation in algebra, mostly. And one cool thing about this is that you see how if you use Python's own math module and you try to take a square root or take any nth root, really, you get a decimal. I mean, it is pretty close, but again, it's a decimal and it's not the true value. While in SymPy, even though it doesn't give you a decimal representation, it does retain the true value, the exact value in symbolic form. So you can see the square root of 8 obviously simplifies down to 2 times the square root of 2. And you don't just have to create one symbol per line. You can actually generate, like, assign multiple symbols in the same line, like that. And it prints it out neatly.
Okay, so SymPy can be used to essentially print in latex like this.
Essentially, yeah.
Okay, and so that's just one of the more basic functions.
Yeah, right. It's very fundamental. Yeah, objective.
Okay.
And like I mentioned earlier, that again, it does have some algebraic capabilities as well. Like you can do factorization and expanding if you have a bunch of terms multiply together. So if you have like some quadratic, like x squared minus 6x plus 8, if you think about it, it's really just these two terms multiply together, and you can do the opposite as well. You can expand out expression of many factors and simplify it down like that. And like I said before, you can run a calculus operation here, and again, it uses latex, so you can do summation symbols. You can probably even do matrix symbol. So anything that's available in latex format, SimPy should be able to do it and print it out. But if you want to specifically copy and paste output, maybe for a publication or into a Word document later, then it does have a latex function that specifically gives you the raw form behind the generation of latex. So this is also pretty useful. And this part, this is the final part. I'm not going to go into the theory, obviously. I'm not a physics major, but it has, I want to say maybe like about 10 different submodules. These are just 3, depending on what type of physics you're studying, but it has pretty much everything you need, at least in undergraduate physics. So you have like your classical mechanics, polyalgebra, and high energy. There's a lot more. There's one for quantum as well. But yeah, so these are pretty much the big 3 libraries that are really helpful for physicists and other people in STEM. The rest of this notebook pretty much covers plotting examples, but I'm gonna revert to Dorad to go through some examples on the slides first.
Yeah. Okay. So, I'll do that then. I'd like to share my screen for the demo side of things as well. So let me see. I'm gonna share my screen instead. So I think I need you to stop sharing.
Sure.
Okay, let's see. Okay, hi everyone. Can you see my screen?
Yes,
I can.
Okay, cool. So with my section, I focused on matplotlib and what is matplotlib and what kind of functions you can use in matplotlib to make essentially any type of plots you want. So for matplotlib, we already went through this slide. So
move this one over there.
Oh, so for matplotlib, what you can do is you can plot different graphs and functions. So for this example, I imported numpy and matplotlib.pyplot as PLT, and essentially this line of code here, it imports the library matplotlib, and I set as a variable PLT. So for this example, I'm just going to have I want to plot an exponential function. Let's say I want a graph of an exponential function. How would I do that in matplotlib? So first I'll need to use some a regular list of a Python list. This is not this is not in NumPy. It's just a standard Python feature. You can make a list of numbers. So it's just going to have x is equal to 1, 2, 3, 4, and 5. It's not continuous between those 2 numbers, but it's just 5 different x values. Next, I'm going to have a function of e to the x, which is an exponential function. So I set y equal to the e to the x, and I used numpy to call out that specific function, the e function. And essentially this is the same as having e to the x. So this would be your e, and this would be to the power of x. So in matplotlib exclusively, you can use plt.plot to plot one x value in a y value. And what you can do afterwards is use this function plt.show to show whatever plot you're doing So you'll need this. If you just put this, usually you won't see your plot. Afterwards, when you put this in, you'll actually have your plot show. So let's go ahead and demo. Okay. So can everyone see? Yes, I'm assuming. So here. So I'm going to put in import numpy as np and import matplotlib. Going to run that. So let that run. And I'm going to set my my variables x and y with y containing the function e of the x, e of t dx. And this is already plotted, but I'm going to replot it again to show you that, hey, there's a plot of e to the x. But notice that, well, what we want to do is plot a continuous function of e to x, e to the x. Like, let's say if you were to differentiate at x equals 3, you can see that there's a cusp there, and usually in a regular e to the x function, you want to have it differentiable everywhere, which is not the case here. So how would you do that? Well, you can make it more clear by adding more x values simply. So here I use numpy dot line space, and you can, well, in this Google work, I think it was, well, in this particular case, you can hover over it dot np dot line space, and you can see a quick detail of how everything works. So with this particular function, you can start at a specific x value, stop at a specific x value, and fill it in with how many numbers you want. So I have a range, a domain from 0 to 5, and I want 100 points. So that's what I'm going to have, and I'm also going to set a new function, e to the x, e to the x1, which is containing the new x range. So I'm going to do that. And also, let's make it so, like, if you were to publish this graph, it's not a really pretty looking graph. If you were to just submit this as a paper or anything like that, you don't even know what units there are or anything. So let's go back to here, and for this example, the next example, we use line space to have more numbers in our x domain, essentially, to give the impression that we have a differentiable and continuous function of e to the x. But let's get some labels to this plot. Let's make an x value label and a y label. So let's also give the plot a title too, because of the fact that we don't know exactly what we're doing, so we have to give some kind of meaning to this e to the x function. So let's do that. So here, already kind of plotted already, but here I have the regular function with e to the x, but with the 5 separate x values. So you can see that in the background, but you could also overplot different different plots on top of each other. So here I have x1 comma y1. So you can start with your x value and your y value here in plot or matplotlib, and also wanting to set a different color, so you can have a string right afterwards, and it'll recognize that automatically that, hey, I want lime green as my secondary plot. So here we're going to give a kind of purpose and sense to this graph. So we're going to say, this is something random I came up with, the fungal growth on Mars over a period of time. So you know that exponential functions are used for growth and decay. So this is a perfect example for that. So here we have let's just say for our x label, we can have the time in days, And for a Y label, we have the population of fungi. So you can see, over time, there's an exponential relationship. And over time, the fungus or whatever fungus that's on Mars, it's going to increase and increase and increase as a exponential function would. So the gist of it is that you can you can label your plots, with your X labels and your Y labels, and essentially have it where you have different labels on the axes, and you can also have your title as well. So any questions so far on this? No? Okay. So, well, we have these different plots right here. Well, I also forgot to mention that there's another function called PLT scatter, where you can have specific scatter plots. So this is just using the same, well, you can use different points, and to have different points, you'll have PLT.scatter to do that. And you can have it, you can set it as any shape you want. So you can have a marker X, or you can have a marker O. It should point different circles, filled circles, and you can label it different colors as well. So if you want blue, there you go. You have blue dots.
Right. Were you trying to demo like the typing part? I don't think your screen's not on.
It's not sharing.
Yeah.
I can see it on my side, so I think.
Yeah, it's not with the Google with this link, it's not live. You won't see it live like you would on a Google Docs, at least from my experience. So you won't see the changes readily, so you have to refer to the screen share for this. But over time, after I save it, then you can see it, So any other questions? Okay. Oh, was that a question? No.
Can you make the Google Colab public?
It's private.
Yeah, it should be public, but even if it was if it's private, then we have to fix that. It should be public for everyone. Okay, so I think
I can make it like public after.
Yeah.
Like you mentioned,
Okay.
logged on with my Google account, so
Okay, so yeah, we'll fix that in the background. I'm gonna continue on the next plots. So here, we have our different plots, and let's make this red to differentiate between the different plots here. Now, let's say if you want a legend here to exactly show what does this green plot mean, what does the blue plot mean, and it kind of looks like a secant line between 2 points. If you took Calc 1, you'll know that, hey, this is the slope between 2 points, 4 and 3, x equals 4 and x equals 3. So let's say if you want to differentiate that in the legend, and let's say if you also want, let's say if I want to, for example, if I'm in dark mode on my computer, this doesn't look so nice. So let's say if you want to also fix that and make it more appealing in a dark background, or if you have a presentation about astronomy and all of your slides are black to represent space, but your plots stick out like a sore thumb, you want them to like kind of blend in, you can also do that in Matplotlib. So here, I put everything in a function in Python, but essentially what I'm gonna go over that as well. But essentially here, what I did was I used plt.style.use. So this function has a plethora of predetermined styles to your plot. There's also different ways to manually tweak your plot as well, but the simplest way is to just use a different style. using the style.use function. And there's dark background, and there's a lot more and different ways how to customize the color and skip the theme of your plot. And all of that is covered in Matplotlib's documentation. So you can search that on Google and you'll find what I'm talking about here. But essentially when I run this, then they'll automatically have the plots turn to black, and then all of the black text turn to white to have a better theme matching with the computer or whatever medium you're going to present your plots in. So I'm going to introduce some more advanced techniques as well, along with the legend. So let's say if you want to modify specific features of your plot, like if you want to modify your x-axis, if you want to modify like the color of the ticks, if you want to let's say if you want to specifically change the size of your fonts of the ticks. So when I mean the ticks, I mean like you can't see it here because it's in dark mode, my bad. So like the 0, 1, 2, 3, 4, that's the ticks, what I'm referring to. If you want to make those bigger, you can use this method. So what I did was I set fig and AX, which is short for your axis, and fig is short for figure, and I set that equal to plt.subplots and here. So you can just use plt.subplots. If you want to have a specific sides for your plot, you can use this piece of code here. So fig sides is equal to your x and your y component of your sides of your plot. So if you want to make it bigger, you can put 10. You can also put 10 here to make it bigger, and I'll run it afterwards. I can run it now, and you can see. Let's see, what's this? So ax.plot invalid syntax. Let's see. Oh, I forgot my parentheses here. So let's run that again. So you can see that it's a bigger plot. Let's increase that to 15. It's even bigger plot. So you can increase the size of your plots, decrease the size of your plots using this line of code, and this will be available to everyone to use. So let me get through this a little bit quicker now. So let's get through how I got to this legend. So using this format here, and just really quickly, I put all of this in a function, and I return it as a of x. So in Python, there's functions you can use, as I'm sure like almost all the members of SSD would know this, but you can set different functions in Python, and you have whatever lines of code you want to repeat on call. You can use this function here as after you define it, and it return everything as a access function. I'm not using the proper terminology, but just know that when you plot this or like call this at will, which is right here, and set that equal to a of ax, you can essentially call all of this, the tweaking to your plots and everything. You can call it at will and then add more to it afterwards. So here for the ax.legend, it's just going to plot a legend, but it's not going to plot anything in that legend. So to give more character and to actually show what you're going to like, to actually give like labels to each and every plot, you simply give in another parameter here, label is equal to whatever text you want. So for this one, this is going to be the blue, this blue plot here. I want that to be the secant line between every interval of 1 day. So that would be our secant lines, and that would be, you know, the slope between 2 points. So I want that to be in part of the legend, and that's going to be in blue. And by the way, aside note, the reason it's in blue is because matplotlib has a already predetermined set of colors for your plot. So if you don't label anything, the first one is going to be blue, or like a navy blue kind of thing. So I'll put label as second line. For the next one, I set this one to be lime green color, and that's going to be the better looking e to the x function. So I'm going to label function of growth, and you can also put in any kind of equations in LaTeX using these dollar signs and whatever LaTeX function you want. If you want to know more about that, I can give a link about that after the presentation. But essentially, this is just going to have e to the x here. Oh, this should not be e to the y. That should be e to the x, and it'll have it in LaTeX. So it'll make it look nice. Your e to the x instead of having in ASCII. So then you'll have your scatter plot here, and I want this to be, since this is not like a function, this is more like different points. I want this to be, let's say someone on Mars found that they had different data points of this fungal species growing at an exponential rate. So they only have it at day 1, day 2. They didn't continuously sample it. So they're going to have 5 different points, and everything in between is the e to the x function. So you can put everything as label, and once you call this function ax.legend, then it'll take whatever you have as a label, as your label parameter, and it'll take everything else into consideration, like the color of your label, the color of your plot or your scatter plot, and it'll also automatically give you what type of line it is, what kind of scatter plot it is, and the text that you put as well. So here I just made it look a little bit more fancy, to be honest. What I did was I defined f of x as the e to the x function from NumPy, and you can just see here, you can clearly see that here for like m, I added some extra plots as well to, let's say, this pink line here. Let's say if you want to determine the instantaneous rate of change at the t equals 3.5 days, that pink line represents that tangent line, and I can you can see right here that this is in fact the equation of I think it's the equation, just the equation of the line. But recall that if you want the instantaneous rate of change, you have to take the derivative of the function, and the derivative of the function is just e to the x. So that's why I simply just called on e to the x to begin with, because that's the derivative of e to the x. So yeah, the derivative of e to the x is just e to the x, and you can just use that to plot a line in the slope-intercept form. So that's about it so far. Also, one more thing, you can also overplot any kind of text you want to matplotlib. So you can label the coordinates of your plot. In this case, it's in pixel coordinates. So whatever you have here, if you 1 to 0, you can have a text starting there, and then you can essentially put in whatever string you want. So any questions on that so far? No? Okay. So I'm going to keep going. And there's one more thing I want to mention before I leave this example. You can also change the limits of your plot. So the limits of, like, when I mean limits, I mean like you can zoom in and zoom out of each function you want. So let's say if I want to zoom in particular where this tangent line occurs, well, so I'll put that as a function. Well, I use this matplotlib function dot axes, and it gives you the starting x, the end of x, the start of y, and the end of y. So you can kind of zoom in on the plot using these numbers. So if you want to zoom out a little bit more, well, you can put 5 and put 0 here. And when you plot that, you can see it zooms out. So think of it as where you're back in Calc 1, you can zoom out on your graphing calculator, your TI-85, or if that's what it's called. So, well, that's it for this function in this example. So I'm going to keep going. Ignore this. I was trying something out. So let's say you want to plot, let's say if you have a CV file, or if you have some other file, and if you want to visualize that data set. So you can do that with the other included libraries. Well, this is a FITS file. This is a little bit more complicated. No one probably heard of this before, but this is a file for astronomers. And essentially, they contain images or they can contain spectra. And spectrums are essentially a two-dimensional plot. And in this case, I did the hard work of trying to find the spectrum of the sun for no particular reason other for this presentation. And here, what I did was you can essentially plot whatever data sets you want into Matplotlib. So in this case, it plots it as a NumPy function. And you can plot essentially whatever data sets you want here. And let's go back to the slides really quick. Oh, looks like I skipped a little bit. But let's say this is just another example of overplotting data on top of this. So let's go back here. So so let's say if you want to make a function, a Gaussian curve, which is really popular in physics, and if you want to essentially fit a Gaussian curve to one of the peaks, like let's say if you want to fit a Gaussian curve to this peak to measure exactly how high it is. So to do that, what you would do is you'll create your function first. So this is this Gaussian function, and you can label it, you can create it in Python with this line of code. And here as a function, you can call on different parameters as well as just calling on and repeating whatever that's inside of that function. So here I have the values of x, a, dx, and the initial x value, which is the exact same here. And when you call it, let's say Gaussian, if you call Gaussian here, you can put exactly what numbers you want for x. So if x is 2, your a is your amplitude, in this case that'd be 6. Your dx, which is your width of your Gaussian line, 7, and it's your starting initial point. Okay, well will be just x would just be x. So my bad on that, but x is essentially the domain of the Gaussian is all real numbers. So I know that I'm running out of time here, but it's all real numbers. And what I did here on this line is that I set x to be line space between 0 and 50,000, and that essentially gave me a nice continuous curve. So here you can see I zoomed in using axis here, ax.axis, and I zoomed in a little bit to see the sun's spectrum. So essentially these dips are the absorption spectrum of the sun. So these represent different chemicals that's on the sun's surface. So if you want to fit exactly where those peaks are, or in this case the absorption lines are, you can fit different Gaussians to them. So here I kind of guessed it, and here you can just for any kind of values you want, you can overplot over different functions. You can overplot with the functions you use. So any questions on that? No? Okay. So I know we have like 5 minutes, so this is essentially more of the same thing. But in this case, if you want multiple plots in one plot, well, you can use something called the subplot. And essentially what the subplot is, if you hover over this, well, that doesn't... Okay, so subplots, you have, let's say if you want a 2x2 arrangement, so you can have a 2x2 arrangement. So if you want a 1x4 arrangement, you can put 1x4, and then instead of this, it'll have all the plots in the line. And this number here dictates what plot you're looking at. So matplotlib likes to look from left to right, and if there's no more on your right, it goes down here. So then this is your first, second, third, and fourth in order, and you can plot multiple plots in one plot. So here's an example of that, and this data set actually comes from US Fun weather station. And if I plot it, well, let me load this in and load this in here. This is actually live data from the weather station. So, oh, looks like it rained recently. Did it rain recently in Gainesville? I'm in Gainesville. Yeah, so this is what matplotlib is for. It's for that visualization. And this is, well, you can also turn off the axis using plt.axis and set a string to be off. So it makes it look really nice, especially if you have everything else black. So yeah, that's really interesting. One more thing I want to do, mention before I cut it off, is that you can image using matplotlib as well. So it's not just limited to plots. You can actually image different things, like if you want to image a galaxy, if you want to image a galaxy cluster, if you want to image exactly how, well, I'm not a particle physicist, but like if you want to image an atom, or like how, like, or let's say if you have an x-ray of something, if you want to image that, you can do anything you want in matplotlib in terms of imaging. So we had a conversation within NSBP about medical physics and the importance of medical physics and computer science. So here's a quick example that I have created, and I got a little help from NIBABL. I don't know how to pronounce that, but essentially this is another Python library that I installed. And just really quick, if you like medical science, if you want to use Python in medical science, here's your chance. And let's go back here. So I installed that library, and you don't have to know exactly what I did here. Just know that I loaded someone's brain onto here. So that's interesting. And let's say if I want to look at that brain, well, you can use the function ax. Well, in this case, it would be ax.image show, and you can plot anything you want in terms of a numpy array. So in this case, this array is 3-dimensional because it's a 2D plot with different values within it. So, and you can also set the map, or the CMap, the color map of whatever brain you're looking at, or whatever image. It doesn't have to be a brain. So that's essentially it. Oh, let me go a little bit more in detail. So with this, so you can set different types of color maps. So let's say if you want something more, if you want a different color map, there's a color map called Inferno. No access. Okay, so, well, I had downloaded the file here. Let's see if I could do something really quick. /home/ can I get to that? Okay. There's nothing there. Oh, that's unfortunate. Well, good thing I plotted these already, but essentially if you want CMap Inferno would look something like this plot right here, which I plotted. So you can change the color maps of each plot you have. and you can also include a color bar as well. So to do that, you can't just simply plot plt.colorbar. You have to have some kind of what matplotlib calls it mappable. So essentially, you have to call in the image you're showing into this mappable. So you label it as a variable and set mappable to whatever variable you have. In this case, it's that entire image, and it'll automatically translate. And then afterwards, you can set whatever map you want. So here's another one. You can just use rainbow. I think that's one of the C maps. And again, you have a list of preset color maps on matplotlib's documentation. So yeah, and also you can overplot on top of maps as well using the same methods as before. So yeah, here shows images, and you can see there's different color plots, and that's about it. So that's it about matplotlib. So any questions before I cut it off on matplotlib? Okay, well that's it. So I'll leave it to Kajun now.
Yeah, so as you saw, matplotlib was like very useful, especially for images. So I want to add just really quick that it's pretty much compatible with so many libraries. Like I'm in machine learning, and people usually use like OpenCV to edit and put different filters on images for computer vision. So really there's like pretty much unlimited interoperability. But it's just something really cool. Slide. I think I lost control, but okay. But thanks for coming. There's just some announcements for both our organizations that we want to briefly glance over.
Yeah, NSBP, do you have any announcements right now?
Rod, I think you're muted.
Wait.
Oh yeah, I'm on mute. So your guys' announcements are supposed to be on here. I don't know what happened to it, but here the announcements we have a guest speaker. His name is Jake Rosenwig. I think I butchered that name. He's a particle physicist as part of our particle physics theme for this month, and he's a PhD candidate, and we're going to have a talk with him. So if you want to know more about particle physics, his work, and his and essentially his path to becoming a particle physicist, come join us in an online Zoom conference. It'll be more of a casual talk, I think, and it'll be this Friday at 7 p.m. We're also going to have game nights, which we're just going to play pool. I think, that's exactly the next week after. So, exactly the next week after Friday, and also we plan to have a geophysicist guest speaker at October the 8th. So those are our announcements so far.
All right, so SSD doesn't have a lot of announcements, so we have a hackathon this Saturday in room Franklin in the Marston basement. Just come chill, work on personal projects, homework, whatever you guys want. Also, future meetings will be held on Zoom as always, but also at Wheel 234. Wheel 234. The registrar finally got back to us and gave us a room, so that's great. So thank you so much for NSBP for co-hosting this meeting. Thank you all for coming, especially for those of you who have been here since 6:15. This has likely been SSD's longest meeting ever. And
No, it hasn't.
no? Okay, well, hopefully it's the longest one in a while. So, well, once again, thank you all for coming, and have a great week, and I hope to see you guys on Saturday.
For those of you who want to teeter with code, I'm also going to make the code public sometime later.
Anyone to chill and talk before running out? Maybe you can do. I don't know, like half of the name. I learned Nick now. Got one.